Welcome to Naradar Academy. In this video, we are going to discuss about Laplace transform. Definition: if f of t is a function which is defined for all positive values of t, and if integral 0 to infinity e power minus st f of t dt exists, okay, then it is called the Laplace transform of f of t. Okay, that is L of f of t. L for Laplace, f of t is the given function, okay, equal to integral 0 to infinity e power minus st into f of t dt, and it is usually denoted by f of s. Okay, and limit of this function, limit s tends to infinity, this f of s is always equal to 0. Okay, this is the definition for Laplace transform of a given function. Next one is, what are the conditions sufficient for existence of the Laplace transform? Three sufficient conditions are there. The first one is the given function f of t must be either continuous or piecewise continuous in the interval a b. Okay, for any finite values of a and b with a as positive value. So what do you mean by continuity? That is, without any breaks, the curve should be there. Okay, if it is not continuous, at least it should be piecewise continuous. Piecewise continuous means if you divide this interval, it is not continuous, fully continuous in this interval. At least if you divide this interval into small intervals, in the small intervals it should be continuous. Okay, that is called what? Piecewise continuous. That is, even though continuity is not there, if you divide the interval into small pieces, in all the pieces it should be what? Continuous. Okay, that is called what? Piecewise continuous. So either continuity or piecewise continuity should be there. Next one is f of t must be of exponential order. What do you mean by exponential order? That is, limit s tends to infinity e power minus st f of t equal to 0. Okay, and t power n into f of t is bounded near t equal to 0. Okay, so these three are the conditions for sufficient conditions for existence of Laplace transform. Okay, in this video we are going to study how to find Laplace transform of the given function, and using Laplace transform how can we evaluate some complicated integrals. Okay, so these are the things we are going to cover in this video. Now before that, let us see some standard results based on Laplace transform. Now if f of t and phi of t are two different functions, then Laplace transform of f of t plus phi of t equal to L of f of t plus L of phi of t. Okay, and L of c into f of t, where c is a constant, is equal to c into L of f of t. Okay, next one, L of f dash of t. F dash means derivative, first order derivative. Okay, equal to s into L of f of t minus f of 0. Okay, this is for first order derivative. Second order derivative, L of f double dash of t equal to s square into L of f of t minus s into f of 0 minus f dash of 0. Okay, in general, for nth order derivative, L of f n of t, this means nth order derivative, okay, equal to s power n L of f of t minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0, etc., minus etc. up to minus f n minus 1th derivative of 0. All these formulas you have to memorize, then only you can do problems in Laplace transform. Okay, so these are like integration and differentiation formula, so which are the basic for doing problems under Laplace transform. Next one is two theorems we have. One is called initial value theorem, another one is called final value theorem. Limit t tends to 0 f of t equal to limit s tends to infinity s into f of s, and final value theorem is limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. Okay, and here we are going to see Laplace transform of some standard functions. Laplace transform of e power minus at equal to 1 by s plus a and e power at equal to 1 by s minus a. If it is minus here, it has to be plus. If it is plus, it has to be minus here. Okay, and L of cos hat, hyperbolic function, equal to s by s square minus a square, and L of sin hat equal to a by s square minus a square. Okay, for hyperbolic function, the denominator will be s square minus a square, and for cos it will be s by, and for sin it will be a by s square minus a square. And our circular trigonometric function, L of cos at and L of sin at. For cos at it is s by s square plus a square, for sin at it is a by s square plus a square. You see the difference? For hyperbolic function, the denominator is s square minus a square. For circular trigonometric function, it is s square plus a square. Okay. Then for cos it is s in the numerator, for sin it is a in the numerator for both the functions. Okay, right. And L of t power n is equal to gamma of n plus 1 by s power n plus 1. This is gamma function, and the value of gamma of n plus 1 is nothing but n factorial. So L of t power n equal to n factorial by s power n plus 1. Okay, if you put n equal to 0 here, what happens? L of t power 0. T power 0 equal to what? 1. So L of 1 equal to 0 factorial by s power 1. What is 0 factorial? 1. So L of 1 equal to 1 by s. And L of t power half is equal to root pi by 2 s power half. So all these are derived from the definition of the Laplace transform only. Okay, from the first page we have studied what is the definition. No, in that definition only, from that definition only we have derived all these formulas. So it is better you memorize all these formulas. Okay, suppose if we have a periodic function f of t with period a, then its Laplace transform is defined to be 1 by 1 minus e power minus as integral 0 to a e power minus st into f of t dt. Why this is so? Because periodic function means what? It will be repeatedly taking the same values, isn't it? That is, from 0 to a it will assume different values. Then from a to 2a the same values will be repeated, isn't it? That is called periodic function. So periodic function, the definition will reduce to this format. Okay, right. Then next one, L of f of at equal to, okay, suppose you have in the place of t you have f of at, it is equal to 1 by a into capital F of s by a. Okay, while doing the problems you can understand this better. Okay, right. And L of e power minus at into f of t, that is e power minus at into some function, means what you have to do is find the Laplace transform of this function alone. Okay, in that one you replace s by s plus a. Okay, capital F of s means what? Laplace of f of t. Find the Laplace of f of t. In that one s will be appearing, no, instead of that s you have to replace s plus a. And L of t into f of t, t means what? Product of t into f of t means minus d by ds of f of s. What is this f of s? Laplace of f of t alone. So whenever you have the product like this, find the Laplace of this function alone and differentiate it with respect to s. If you have t power n, then the generalized formula is minus 1 power n into d power n by ds power n, nth order derivative of f of s. That is, find the Laplace transform of f of t, differentiate it n times, where what is this n? Power of t. Okay, right. So for product we have seen. What about if t comes in the denominator? So L of f of t by t equal to integral s to infinity f of s ds. What is this f of s? Again Laplace of this f of t. Okay, so this exists only when limit t tends to 0 f of t by t. This limit exists only, no, at the time only we have to calculate this. Okay, so these are the basic things that you have to memorize for doing problems in Laplace transform. Okay, now let us see some problems. The first one, f of t equal to t e power minus 5t. For all the coming problems you have to find the Laplace transform. Now L of f of t equal to L of t into e power minus 5t. See, product of two functions are there. So what I am going to do is I am going to find L of t. In that one I am going to replace s by s plus 5 because it is e power minus 5t, no. So what is the formula I have given here? If it is e power minus 8 into f of t, write the Laplace of f of t. In that one replace s by s plus a. The same thing I have done here. Write the Laplace of t alone. In that one replace s by s plus 5. What is Laplace of t? 1 by s square, isn't it? In 1 by s square you have to replace s by s plus 5. So 1 by s plus 5 the whole square. Okay, right. Then another problem, f of t equal to t square into e power 3t. This is also similar to the previous problem, but I am going to do in the other way. In any one of the ways you can do. So first problem, I have applied the Laplace for t and then applied for e power minus 5t. But for this problem I am going to do it in the other way. Whichever you feel comfortable you can do. Okay, right. Now L of t square into e power 3t. What I am going to do is, it is t square, no. So whenever you have product L of t power n into f of t, what is the formula? Minus 1 power n d power n by ds power n f of s. That is, write the Laplace of this f of t and differentiate it n times. In the same way, here I am going to write the Laplace of e power 3t and differentiate it 2 times. Because here it is t square, no. So differentiate it 2 times. So minus 1 square means what? Plus 1. D square by ds square of, what is e power 3t? Laplace of e power 3t? 1 by s minus 3. So differentiate it twice. So first time when you differentiate, what will happen? This is like 1 by x, no? Differentiation of 1 by x is minus 1 by x square. So minus 1 by s minus 3 the whole square. Again you differentiate. This is like 1 by x square, no? What is differentiation of 1 by x square? Minus 2 by x cube. So already one minus is there, it will be plus 2 by s minus 3 the whole cube. Okay, so this is the Laplace of t square into e power 3t. So both the problems are the similar type only, but this problem, first I have applied the Laplace of t, and then for e power minus 5t I have applied. Here I find Laplace of e power 3t, there I have applied the product t square. Okay, in any one of the ways you can do the problems, right? Then next one, f of t equal to t into cos t. So product term, no, t into cos t. So we have to take differentiation, isn't it? So whenever you have product t into something, minus d by ds of Laplace of this function alone, cos t. What is Laplace of cos t? S square by s square plus a square. Here a is 1, so s by s square plus 1. So you have to differentiate this. So both numerator, you have to differentiate with respect to s. Both numerator and denominator are having s, no? So you have to differentiate this by u by v method. For u by v method, what do you have? Denominator, it should be v square. Numerator, v into differentiation of u minus u into differentiation of v. So put s square plus 1 the whole square. So s square plus 1 into differentiation of s is 1 minus s into differentiation of s square plus 1 is what? 2s. So minus 1 by s square plus 1 the whole square into minus s square. So simplify this one, minus s square plus 1. So it will be simply what? S square minus 1 by s square plus 1 the whole square. Okay, right. Next problem, f of t equal to t into cos square t. Okay, right. So t is there, no? So what should you do? Minus d by ds, differentiation of Laplace of cos square t. But cos square t, we don't have Laplace transform, so I have to rewrite it. What's the formula for cos square theta? 1 plus cos 2 theta by 2. So let me substitute it here. So Laplace of d by ds of Laplace of 1 plus cos 2t by 2. So keep this 1 by 2 outside, minus d by ds of Laplace of 1 plus Laplace of cos 2t. Okay, what is Laplace of 1? 1 by s. Plus Laplace of cos 2t is s by s square plus 4. What is this? S by s square plus 2 square. Okay, right. Now you have to differentiate this expression. So now differentiation of 1 by s is minus 1 by s square plus, here we are differentiating with respect to s. Both numerator and denominator contains s term. So we have to apply u by v rule, quotient rule. So s square plus 4 the whole square in the denominator. Here s square plus 4 into differentiation of s is 1 minus s into differentiation of s square plus 4 is 2s. Okay, simplify. So what I get? 1 by 2 s square plus s square minus 4 by 2 into s square plus 4. Okay, right. Next problem. F of t equal to 1 plus t e power minus t the whole square. Okay, now we expand this by using a plus b the whole square formula. So 1 plus t square e power minus 2t plus 2t e power minus t. Now you take Laplace on both sides. So Laplace of 1 plus Laplace of t square e power minus 2t plus 2 into Laplace of t e power minus t. Laplace of 1 is 1 by s. Here write Laplace of Laplace of t square. T square means what? 2 factorial by s cube. In that one you have to substitute s equal to s plus 2. Isn't it? Right. Plus 2 into, here also product. So write the Laplace of t. So 1 by s square. In that one you have to replace s by s plus 1. Okay, this will be comfortable. Instead of differentiation, this will be comfortable for me. So I am proceeding in this way. If you don't want to proceed in this way, what you have to do? Write the Laplace of e power minus 2t, differentiate it 2 times here. Because t square, no. Here, write the Laplace of e power minus t and differentiate it 1 time. Okay, comparatively this will be simpler. So here I am writing t square, Laplace of t square, replacing s by s plus 2. Here Laplace of e power minus t, replacing s by s plus 1. So what will I get? 1 by s plus 2 by s plus 2 the whole cube plus 2 by s plus 1 the whole square. Okay, then next problem. F of t equal to t square into sine 2t. Okay, so here product we have. So for t square, what should you do? Minus 1 square into d square by ds square of Laplace of sine 2t. What is Laplace of sine 2t? 2 by, that is a by s square plus a square. So 2 by s square plus 4. Now you have to differentiate it twice. It is like 1 by x, no? What is differentiation of 1 by x? Minus 1 by x square. So minus 2 by s square plus 4 the whole square into, here it is s square plus 4, no? So what is its differentiation? 2s. That should come in the numerator. That is, I am applying chain rule for differentiation. because this is not simply s term, it is s square term. Okay, so I should put differentiation of this term in the numerator. So what I get? Minus 4 into d by ds of s by s square plus 4 the whole square. Now this is quotient rule we have to apply for differentiation. Minus 4 into s square plus 4 the whole power 4. Square term is already there, no? So when you square it again, it will be power 4. S square plus 4 the whole square into 1 minus s into differentiation of this is 2 into s square plus 4 into 2s. Now you simplify this expression. Finally I am getting 4 into 3s square minus 4 by s square plus 4 the whole cube. Okay, then next problem. F of t equal to t into sin hat. So since t is there, what is the formula? Differentiation of Laplace of sin hat. For sin hat, the Laplace is what? A by s square minus a square. Here it is hyperbolic function, so a by s square minus a square. Now what is its differentiation? A into, this is like 1 by x, no? 1 by x means what? 1 by minus 1 by x square. So it will be what? Minus into minus will become plus a by s square minus a square the whole square into 2s. So L of f of t equal to 2as by s square minus a square the whole square. Next problem, f of t equal to t e power minus t into cos t. Here you have product of three terms. Let us apply one by one. Okay, first for removing this t, I have to put d by ds. d by ds of Laplace of e power minus t into cos t. For removing this e power minus t, you have to write Laplace of cos t. In that one you have to replace s by s plus 1. What is Laplace of cos t? S by s square plus 1. In that one you have to replace s by s plus 1, isn't it? So minus d by ds of s plus 1 by s plus 1 the whole square plus 1. So minus d by ds of s plus 1 by s square plus 2s plus 2. Okay, now differentiate this by means of u by v method. So what I get? Denominator, it will be s square plus 2s plus 2 the whole square. Numerator, s square plus 2s plus 2 into differentiation is 1 minus s plus 1 into differentiation of this term is 2s plus 2. Okay, now you simplify. So what do you get? Simply Laplace of f of t is equal to s square plus 2s by s square plus 2s plus 2 the whole square. Okay, next problem. F of t equal to 1 minus cos t by t. So here t comes in the denominator. So whenever t comes in the denominator, its Laplace is given by integral s to infinity Laplace of 1 minus cos t. So this is Laplace of 1 is 1 by s minus Laplace of cos t is s by s square plus 1. Integrate this. 1 by s integration is log s minus integration of s by s square plus 1. See, denominator is s square plus 1. If you differentiate this, you will get 2s. Only s is there in the numerator. So multiply and divide by 2. So 2s by s square plus 1. So okay, minus half into log of s square plus 1 within the limits s to infinity. If you apply the upper limit, the entire thing will become 0. Okay, only lower limit will come. So when you apply lower limit, you have to put minus sign. No? So it will be minus log s plus 1 by 2 into log of s square plus 1. Okay, so for writing this in a convenient form, I am multiplying and dividing by 2 here. So 1 by 2 into the numerator 2 will go to this power. So minus 1 by 2 log s square plus 1 by 2 log of s square plus 1. It is simply what? Log a minus log b. So log of a by b. Okay, right. Next problem. F of t equal to t into sin hat. So here it is in product form, no? So minus d by ds of Laplace of sin hat. Sorry, I think I have already discussed this problem. Sorry. Okay, next problem. F of t equal to sin square t by t. Since we have t in the denominator, what should you do? You have to take integration. So before that, let us rewrite this term sin square t. Sin square t is what? 1 minus cos 2t by 2. So since we have t in the denominator, it is half into integral s to infinity Laplace of 1 minus cos 2t ds. Laplace of 1 is 1 by s minus Laplace of cos 2t is s by s square plus 4. So when you integrate, this is log s minus this is also as before the previous problem. If you differentiate the denominator, the numerator is coming but 2 is missing. So I am multiplying and dividing by 2. So minus 1 by 2 into log of s square plus 4. Apply the limit. If you apply the upper limit, it will be 0. When you apply the lower limit, it will take the negative sign. So minus log s plus half into log of s square plus 4. Again you multiply and divide by 2. So the 2 in the numerator will become as log s square. Minus 1 by 2 log s square plus half into log of s square plus 4. So this is like log of a by b. Okay, right. Then next problem. Here these are another set of problems which we are going to evaluate the integrals by using Laplace transform. Okay, look at the first integral. Integral 0 to infinity t e power minus 3t sin t dt. Okay, if you want to evaluate this integral, it will be too complicated. But using Laplace transform, we can find the answer in 1 or 2 steps. See, what is L of f of t for any function? Integral 0 to infinity e power minus st into f of t dt. Okay, here, this is also in the same type. So, L of t into sin t, how will you write? Remove this e power minus 3t. What do you have? T into sin t. So, what is Laplace of t into sin t? As per this definition, integral 0 to infinity e power minus st t sin t dt. Both are same only, no? But in the place of s, what do you have? 3. So, instead of evaluating this integral, I can find the value of L of t into sin t. In that one, I have to replace s equal to 3. What is L of t into sin t? T is there, no? So minus d by ds of sin t, Laplace of sin t. Laplace of sin t is what? 1 by s square plus 1. So differentiate this. This is like 1 by x, no? Differentiation of 1 by x is minus 1 by x square. So 1 by s square plus 1 the whole square into, by chain rule, differentiation of s square is 2s, no? That you have to put in the numerator. So this is the Laplace of t into sin t. But here what should you write? S equal to 3. So if you put s equal to 3, what will you get? 2 into 3 by 9 plus 1, right? 6 by 10 square, 100. So it's equal to what? 3 by 50. So the value of the integral is 3 by 50. Next problem. Integral 0 to infinity e power minus 3t minus e power minus 6t by t into dt. See, here you are having t in the denominator. When you have t in the denominator, you consider integral 0 to infinity e power minus st into this function dt. So this is nothing but Laplace of e power minus 3t minus e power 6t by t. But what is the Laplace of this one? Integral s to infinity Laplace of e power minus 3t minus e power 6t. Because when you have t in the denominator, it will be integration. So what is Laplace of e power minus 3t? 1 by s plus 3 minus 1 by s plus 6 ds. Now integrate this. Log s plus 3 minus log s plus 6. Within the limit s to infinity, upper limit will become 0. So when you apply the lower limit, the sign get reversed. So minus log s plus 3 plus log s plus 6, it's equal to log s plus 6 by s plus 3. Now, this is the value of this integral, but I don't want this e power minus st in my question, isn't it? So, for that, what you have to do? Put s equal to 0. Okay, so put s equal to 0, then you will get the value of the required integral. S equal to 0 means what? Log 6 by log 3. So, equal to log 2. Okay, right. Then next problem. Integral 0 to infinity cos 60 minus cos 4t by 2. This is of the similar type as we discussed before. So for this type of integral, consider integral 0 to infinity e power minus st into the given function dt. This is nothing but Laplace of cos 60 minus cos 4t by t. Okay, when you get t in the denominator, it is integral s to infinity Laplace of cos 60 minus cos 4t dt. So it's equal to s by s square minus 36 minus s by s square plus 16. So what is its integration? So denominator, differentiation of denominator equal to numerator, but 2 is missing. So multiply and divide by 2. So half into log of s square plus 36 minus half into log of s square plus 16 within the limits s to infinity. When you apply the upper limit, the entire thing will become 0. When you apply the lower limit, the sign gets reversed. So minus half log of s square plus 36 plus half log of s square plus 16. So simply what you have? Half into log of s square plus 16 by s square plus 36. So this is the value of this integral. But in the given question, there is no exponential term. So you put s equal to 0. Then this will become 1. Okay. So when you put s equal to 0, you get half log of 16 by 36. It is 4 by 9. When you bring this half to this side, it will become power of this number, 4 by 9. So 4 by 9 power half, it is simply what? Log of 2 by 3. Okay. Then last problem. Integral 0 to infinity e power minus t sin t by t. Here already we have e power minus t. So consider e power minus st sin t by t dt. So what is this? Laplace of sin t by t, which is equal to integral s to infinity L of sin t ds. L of sin t is 1 by s square plus 1. Integration of this is tan inverse of s, isn't it? Within the limit s to infinity. Now you substitute the limits. Tan inverse of infinity minus tan inverse of s. Tan inverse of infinity means 90 degree, pi by 2 minus tan inverse of s. But in my question, it is only e power minus 1t, not s, it is 1. So put s equal to 1. So what I am getting? Pi by 2 minus tan inverse of 1. Tan inverse of 1 is pi by 4. So pi by 2 minus pi by 4 equal to pi by 4. Okay, that's all. Thank you.